Alright, so the instructions for 73 are to condense. So what that means is we're going to convert this 3-logged expression into a single log. So remember, the coefficients become exponents. Okay, so these 3. So I'm going to write this as log base c of x to the negative 9 plus log base c of y to the negative 4 plus log base c. Oh, and that was a typo, by the way, right here. I know on the handout it says x, but it should be y. And then z to the 1/3. So this is the sum of 3 logs, right? So the sum of logs is the log of the product. So I'm going to convert these 3 logs into a single log, doing x to the negative 9 times y to the negative 4 times z to the 1/3. Now the negatives have to become positive, you turn them to positive to simplify. So this is log base c of x to the 9th, y to the 4th, and then the 1/3 power, we just change it to a radical. And that's the answer right there. Alright, so now we're doing the opposite of number 73. We're actually expanding this. So the 5th root of this fraction, would be this. X to the 4th, y to the 9th over z to the 3rd, all raised to the 1/5 power. So we're going to distribute that 1/5 power, and it becomes log base a of x to the 4/5 times y to the 9/5 divided by z to the 3/5. Okay, so now I'm going to use the properties to expand this. So remember, the log of a product is the sum of the logs. So in the numerator, I have log base a of x to the 4/5 plus log base a of y to the 9/5, and then the quotient is subtraction. So minus log base a of z to the 3/5. And remember, these exponents become coefficients of their respective log. So for example, 4/5 log base a of x plus 9/5 log base a of y minus 3/5 log base a of z. So that would be the answer. After going over number 74, 75 is a piece of cake because it's just a log of a product. So this would be log base c of x to the 4th plus log base c of y to the 5th. The 4 and the 5 become coefficients of their respective logs. And that's the answer. Alright, so we're back to condensing. So we're going to write this expression as a single log. So we're going to use the order of operations. So first we're going to simplify this. So ln x minus the sum of the logs is the log of the product. So natural log of x plus 9 times x minus 9. So now I have the difference of the logs, right? So this becomes the log of the quotient. Now you can leave it like this as a final answer. I'm okay with it. I know in the handout they wrote it as, they distributed like that. So either one's fine. For 77, we're expanding again. Okay, like 75 and 74. So this is a log of a quotient, so this becomes natural log of 11 minus natural log of e to the 7th. The 7 becomes a coefficient, so this is natural log of 11 minus 7 natural log of e. But remember, natural log of e equals 1. So 7 times 1 is 7. So this is natural log of 11 minus 7. And that's the answer. 11 minus 7, you do not subtract, okay? Because the 11 is attached to the natural log. So you keep the answer as I have it right now. Alright, so this is log base 2/5 of 5, and it says use the change of base formula because our calculators, remember, do not have that base, right? So we're going to say either log of 5 over log of, you can keep it as 2/5, but I would probably put it as 0.4, 2 divided by 5. It's easier to input into the calculator. Okay? Or you could put natural log of 5 over natural log of 0.4. Now, I don't have a calculator with me right now, but this is simple enough for you guys to input, and then you have the answers on Google Classroom. So just input it into a calculator and check with the document in Google Classroom. Okay, so either one of these, doesn't matter which one you choose, both of them work. Alright, so for solving this equation, we need to isolate the base e with the x. So this is going to be isolated, okay? So first thing we do is, let's see, plus 12. So you get 3e to the x equals 13. Then we divide by 3. Okay, so now we have e to the x equals 13/3. Do not change it to a decimal because this decimal doesn't end, right? It goes on forever. So just keep it as 13/3. And what I like to do is just change the form. Okay, you could take the log of both sides. That works, of course. But I just change the form. So e to the x equals 13 becomes natural log of 13 over 3 equals the exponent x. So I put it into the calculator exactly as you see it. Natural log, left parentheses, 13 divided by 3, close the parentheses, equal. Okay, don't forget the parentheses. So this would be the exact value. Again, just like with 78, check your answer on the Google Doc. In Google Classroom, the answer key is there. Alright, for 84A, they give you the equation, and they're asking for what is the population at t equals 4. So when you replace the t with 4 and you multiply it by 0.078, you get 0.312. And then this is how you input it into the calculator, right here. Remember, the e is already programmed with a power right after it, so whatever you put after is the exponent. And just check your answer with the Google Classroom, because I don't have a calculator with me right now. So on B, they're asking after how many hours will the population reach 148,350. So you want to, because we're solving for t, you want to isolate the e to the power. So we divide both sides by 64,500. Again, I don't have a calculator, so you guys probably do. So input this into the calculator. And so now you'll have e to the power of this, right, equals whatever you get here on the calculator. So we would say natural log of whatever we get here. I'll just put the whole number divided by 64,500, right? You guys already have the number, whatever that is simplified, equals the exponent. Remember, the log equals the exponent. I'm like a broken record. The log equals the exponent. So here's the log, and here's the exponent. Now we're solving for t, right? So we're going to divide both sides by the coefficient of t. So you already have this value, right? Or from an earlier step. So you took the natural log of it, divided by this, and that will give you t. And just check your answer in the answer key on Google Classroom.